everybody. I am Anusha from CSC department working as assistant professor in Institute of Aeronautical Engineering. In my videos, I was discussing about programming with objects. In the last video, we had discussed about swing features, swing and swing components. In today's video, we will be discussing about applets. Now, what are applets? An applet is a Java program that is embedded into a web page. So it always runs inside the web browser and works at the client side. It is embedded inside the HTML page using the applet or object tag and hosted on a web browser. The applets are used to make the website more dynamic and entertaining. They are small applications that are accessed on an internet server, transported over the internet, automatically installed and run as part of the web document. After an applet arrives on the client, it has limited access to the resources so that it can produce a graphical user interface and run various computations. So these applets are the Java programs which are embedded inside a web page and they work at the client side of the program. Now these applets are all subclasses of the Java applet class. They are not standalone programs, but they are run within the web browser or an applet viewer. The JDK provides a standard applet viewer tool called Applet Viewer. The execution of an applet does not begin at main method. It runs the output of these applet windows are handled with methods like as drawString. So these applets don't contain the main method, and if we want to write anything onto the applet, we make use of the method drawString. Now let's look into some of the advantages of applets. They are cross-platform supported, compatible, and a quick execution, and they are scalable. Now let's look into each of it. The cross-platform feature makes it is achieved because the platform independence of applet. They are designed to work across various platforms. The same Java applet can support the game on Windows system as well as Linux systems. Compatibility. These applets can work on any installed version of the Java plugin that exists on the computer. The most recent plugin is not necessarily required. The user is only forced to do an update if the Java runtime environment is outdated. Quick execution. The process of caching is employed by computers to temporarily store in memory frequently accessed data to shorten program runtimes. The applets are normally cached, making their execution across web browsers faster. Next is scalable work. The ability for certain functions to be moved from server side to the client side has enabled application development to be scalable with the use of applets. Disadvantages of applets. Some browsers, especially mobile browsers, which are running on applet iOS or Android, don't support applets run. If a proxy server is applied to a web access, then automatically installation and update of Java may fail. That's why applets can't run with specific requirements unless Java is manually installed or updated. Applets have to tag as trusted applets and they must be registered to Applet Security Manager. The applet cannot work with native methods. They can extract information about client-side machine like name, its Java version, OS version, etc. It requires Java plugin. Now this is the inheritance hierarchy for applet. This applet is the subclass of panel class of the AWT package. This panel class is the subclass of container and component class, which is derived from the object class. So this is the hierarchy of applets. Now, these are the various steps involved in applet lifecycle. The first three, init, start and paint, forms the initial execution part of the applets, and stop and destroy is called to stop the applet. So when an applet begins, The init, start and paint method are called in the sequence, and when it is terminated, the stop and destroy methods are called. The init method is the first method to be called. This method is called only once during the runtime of the applet. The start method is called after the init. It is also called to restart an applet after it has been stopped, or when a browser is maximized, or when the applet's HTML document is displayed on screen. It is also called if the user leaves the web page and comes back and the applet resumes the execution at start. The paint method is called each time an AWT-based applet output must be drawn. This situation can occur for many examples, like when the window in which the applet is running may be overwritten by another window and then uncovered, or an applet window may be minimized and then restored. The paint is also called when the applet begins execution. Whenever an applet must redraw its output, the paint is called. The content to be displayed in the applet is written in the paint method. The stop method is called when a browser leaves the HTML document containing the applet when it is minimized. When it goes to another page, for example, when stop is called, the applet is probably running. The destroy method is called when the environment determines that your applet needs to be removed completely from the memory. The stop method is always called before destroy. The applet does not have main method. An applet begins its execution when the name of its class is passed to an applet viewer or to a network browser. Now, this is the general structure of an applet skeleton. We have this applet code, which is HTML based, and we have the applet class, which extends the applet. And we call our init method initially, which is meant for initialization. Then we call the start method, which starts or resumes the initialization, and it is called after the init method. Then we have the the graphics, the paint method to redraw the contents of the window. The stop method can be called when you want to suspend the execution, or when the applet is stopped, and when the applet is terminated, the destroy method is called, which shutdowns the activity. So these are the 5 methods which is involved in invoking the applet. This is an example for applet. So we have to import the applet package, applet class, and our class must extend the applet class, and we are going to write a statement. This statement is written onto the applet. So we get a simple applet with the statement displayed as given so. So when the paint is called when the applet begins the execution and it wants to redraw the output. The graphic parameters contains the graphic context which describes the graphic environment in which the applet is running. There are 2 ways to run an applet: by running an HTML file or by making use of the applet viewer tool. When we run an applet by HTML file, first we have to execute the applet by HTML file, create an applet and compile it. After that, create an HTML file and place the applet code in the HTML. Now click the HTML file. The class must be public because its object is created by Java plugin software that resides in the browser. Now this is an example. So here we are creating an applet with class name as first, and the paint method is invoked, which will draw the string, which will call the drawString method to display welcome. Now once this is executed, this class is passed to HTML. And when the HTML file is executed, we will get the output. Next is passing parameters to applet. To retrieve a parameter, we use the getParameter method. It returns the value of the specific parameter in the form of a string object. Thus, for numeric and Boolean values, you will need to convert their string representations to their internal formats. We can get any information from the HTML file as a parameter. For this purpose, the applet class provides a method called as getParameter. The syntax is public string getParameter, string parameter name. Now let's look into the drawing of a simple applet. A simple applet message. So here this is our class which is extending the applet. Then we are calling the init method and the paint method. So inside the paint method we are implementing our logic, wherein we are making use of this graphics object G, which is used to set the font, set the graphic features. So we are setting its color to blue. The font is set to Verdana and bold and 15, size 15. Now this font class, this font is set to our graphics. So we get the, we call the set font method and set the font to the given thing, a given font to the described font, and then we are writing this statement onto the applet. So here so when we draw the string, this statement will be of this described font and of the given color. That is why we get, so since we have defined the color to be blue, and the font to be Verdana, and with these features, we get our this statement written onto the applet with the given details. Next, in another example, we are creating an applet to receive an integer in one text field, compute its factorial value, and return it in another text field when the button name compute is clicked. So here what we have is, we have the factorial, wherein we have one text field to read a value, and when the compute button is clicked, it will display the factorial in the another text field. So here we have our class name fact, which extends applet and implement action listener. We are implementing this action listener so that when the button is pressed, it writes the factorial value onto that particular answer text field. So here we are making use of three labels, L1, L2 and L3, and two text fields, T1 two text fields, one button. Now we'll start the init method. So inside the init method, we are setting the applet size to be 400 by 200. We are making use of the flow layout, and we are setting it to, we are making use, these two statements set the layout of that applet to be of flow layout. Then we are creating a label 1 with the statement enter value. So we have the label. This label is obtained using L1, and its color is set to blue. The L1's foreground color is set to blue, and that L1 is added onto the applet. Next, we are making use of the text field, which is allowed to take which is having 5 columns, and the text is set to 0. Initial value is set to 0. Then we are adding that text field onto the applet. Now we are creating a button with the name compute. We are adding some action listener to that button. So whenever that button is clicked, it will trigger the action listener. This action performed method. So then we have this. This button is added onto the applet. Then we have this label, L3 label, which is displaying the factorial. So this factorial is displayed by label 3. Sorry, it is set to label 2, and we are adding that its color is set to blue, and we are adding that label 2 onto the applet. Then we have this text field which will display the answer or the factorial, and that field also is added onto the applet. Now when this button is pressed, when we will enter a value here, and then we will press this button compute. So when that button is pressed, this value is extracted and its factorial is computed, and its that value is displayed in this text field. So that is obtained by the action action event. So when the button is pressed, the action event pressing button is triggered, is created. It is created as an object, and it is sent to the this method. So when that button is clicked, whatever was written onto this text field, so our text field contains value 5 was written, and then we press that button. So when the button is pressed, this value is extracted. So to get that value, we call t1.getText. So that text value is converted into integer and stored it into n. And then we are making use of the factorial logic. So what is 5 factorial? 5 factorial is 5 into 4 into 3 into 2 into 1. So we have to compute this. So for that, we are starting until n is not 0. So we will start from 5, go back till n becomes 0. So we start from 5, and factorial is stored in the variable f. So f value is set to 1. So initially, while n not equal to 0 means n is equal to 5 initially. So when n is 5, f will be 1 into 5, which will be 5. So now n minus implies n is equal to 4. So n equal to 4 means n is not equal to 0. So we can again compute the factorial. So f was already 5. So 5 into 4, which is equal to 20. Then n minus implies n is equal to 3. Now when n is equal to 3, n is not equal to 0. So n is not equal to 0. So factorial f is equal to 20 into 3, which is equal to 60. Then we find now n minus means n is equal to 2. So factorial, again n is less than not equal to 0. The factorial f is equal to 60 into 2, which is equal to 120. And then n minus means n is equal to 1. N is equal to 1. F is equal to 120 into 1, which is 120 itself. And again n minus, now n becomes 0. When n becomes 0 here, the while loop fails and it exits. So now the factorial value f is having the value 120. Now this value has to be written onto the text field. So that text should be set to 120. 120 is stored in the value f, which is an integer. So that f has to be converted into string, and then that string value will be written onto the text. So to write the string, this integer as a string, we call this string dot value of f. So it takes the value 120 as a string, and that 120 value is stored into the text part of this field text tf2. tf2 is our text field which will be storing the value 120. So this 120 is written onto the onto this text field. So this is how we trigger action listeners on the applet program. So that is all for today's video. So in preparing these slides, I had made use of Java Complete Reference Textbook and Samantha Sir's website, who is a professor in IIT Kharagpur, then Oracle website for Java tutorials, and the Java T-Point website. So in today's video, we had discussed about applets, and that is all for today. Thank you for watching my video.
Like, share and subscribe. Hit the bell icon for more updates.